So let's try to work with it now. So let's say that's 2. That's 2. Okay, so that's a square, so 2, 2. Let's say that's 5. Okay? And centimeters, so centimeters, centimeters, centimeters. All right, so we've got the dimensions also now. So let us try to do the easiest thing, which is working out the volume. So volume equals, as we said, base area multiplied by the height. Okay, that's the formula. So the base is a square here. So the base area will be 2 times 2. Okay, length times breadth. And the height is 5. So you end up getting 2 times 2, 4. So 4 times 5, which gives me 20. All right. Now, if you ever wondered why it becomes centimeter cube, it's because you're multiplying 2 times 2 times 5. And the unit of 2 is actually centimeters, right? So right now, that would be centimeter cube. But why? If I had to actually show all the workings, including the notation, so including the unit, it will be like that. So I'm multiplying 2 centimeters to 2 centimeters to 5 centimeters. So if you multiply the numbers only, 2 times 2, 4, 4 times 5, 20. And then if you multiply the units, centimeter times centimeter is centimeters to the square. Centimeter to the square times centimeter gives you centimeter to the cube. So this is how you get centimeter cube. But you don't need to show all these workings on an exam day, because automatically you just need to know that volume is centimeter cube. Not always centimeter cube, but the unit in which you're measuring to the power of 3. And area is the unit you're measuring to the power of 2. Okay, so that's by default what you need to remember. So that was the volume part, which is the easiest one. Now, what if we need to find the total surface area? That's where it becomes more interesting. So total surface area. And as I told you, it's not good to learn as a formula, because if you forget part of it, you can't improvise because you didn't understand the logic. So let's try to approach it from a logical perspective. So basically what you need to do is you need to find the areas of each face of the diagram and add. So if I start with the front one, we have a square here, right? And that square is identical to the one at the back. So I'm going to shade both of these. So the area of the square is 2 times 2. Agree?
Yeah.
And you have it twice, so I put it 2 in front of it. Right? Plus, now I'm going to focus on this side. So I have 5 down and I have 2 up. Right? So if I need to find the area of this side, it's 2 times 5. So it's 2 times 5, and I have it twice because I have this same side on the other side where I'm shading right now with my pen. So you have 2 times 5, and you have it twice again, so you put another 2 in front of it. Now what's left? What's left is the base. The base. So it's a 2 by 5 again, the base. So it's a 2 by 5. And I'm going to shade the base here. Shading it down. So it's 2 times 5. But you have it twice because the base is actually reflected on the top here. The top of the shoebox. So it's 2 times 5, but times 2 again. So that's how you work out the total surface area. And then what needs to happen is you need to simplify. And since you've introduced brackets, you can actually work out what's in the bracket first. So 2 times 2, 4, 4 times 2, 8, plus 2 times 5, 10, 10 times 2, 20, plus 2 times 5, 10, 10 times 2, 20. So you end up getting 20 plus 20, which is 40. 40 plus 8 is 48. So it's 48 centimeter to the square.